Hi everyone, in this video we're going to look at how to use the Desmos graphing calculator, talk a little bit about what an intersection point is and what it could mean, and then we're going to look at what those intersection points mean on your population growth and food supply lab. Let's start with the Desmos graphing calculator. There is a link in Moodle underneath the lab in chapters 8 and 9 section, but if you don't want to log in, you can just Google Desmos graphing calculator. It will pop up right away. If you click on the link inside of Moodle, it's going to open up in a new tab or a new page, and it just goes right to the screen. And it is very, very easy to use. It's much easier to use than, say, the TI-84. And you just type it in like the way that you would write it, really. So if I had y equals 2x plus, I'll say 2. I have y equals, I hit 2x plus 2, and there you go. If I wanted to graph a second line or another graph of any function, you just click underneath it, another one will pop up. I'm going to make this a -1/2, so any dash, a 1, and then to get the fraction bar to come up, you're going to do the backslash. I think that's maybe it's a forward slash. It's the one that is underneath the question mark or above the 8 if you have a number pad, and will pop up right away. I'm going to put a 2 in there. Now the cursor is underneath that fraction bar, so I'm going to have to kick that out to the side by clicking the arrow key out. And then I'll say x, let's say, plus, I don't know, maybe an 8. And you can see I'm off the screen now, so I can click and hold on the graph and then just drag it down. And if I want to zoom in, I can use the plus sign. If I zoom out with the negative side off to the top right. I could also just use the mouse pad or the scroll wheel that if you have an older mouse to see it. If you don't want to look at both at the same time, you can kind of like turn one off. So let's say I have these both on, but I only want to really concentrate on the red line right now. I can click on that blue and it disappears, but then I can click it back on and turn the red one on if I want, or I can turn them both off. I'm going to turn the red line back on. If you click on the line, you can see that some points come up that are gray. Those are going to like be your important points, right? Those are the meaningful points. So here's my y-intercept. Here's an x-intercept. If I click on it, we'll hold on. I can turn them off. When I turn on the blue line, I'll also get an x-intercept when I click on it and a y-intercept. Well, I have said that backwards. There's the x-intercept. Here's the y-intercept. But because I have both on the same grid, you see I got another line right here, another dot right here, and that's the intersection point. So that's where the lines are at the same place at the same time. So if you plug a 2.4 into either one of these equations, they will both spit out a 6.8. Now maybe this is a meaningful intersection point, and maybe it's not. If you just ask to graph two lines and find the intersection point, it doesn't really mean much. But if those lines represent something, so like say cost and profit, when you have a business, then this intersection point would mean something, and that would be the break-even point. So let's say that the blue line is your cost and the red line is your revenue, how much money you're making. This would be the point where you didn't make any money, but you didn't lose any money either. If, let's say I'm going to put in a slider so that I can kind of move this around a little bit, although this doesn't seem to want to cooperate. I'm just going to say like that. Let's say I made just one thing, right? I have one lone item that I made at my business. It would have cost me $7.50 to make it, and I guess I'm selling them only for $4. I would have only made $4, right? So at this point, it's costing me more money than I'm making. But as I get closer to this intersection point, you see how they come together and they're both at the same point at the same time. As I move past that break-even point, now the line that represents the revenue, the red, is higher than what it is down here on my costs, and now I'm starting to make money. So that's the break-even point. Now, if these two lines maybe represented supply and demand, this intersection point would be an equilibrium point. It's like, let's say this red line is my demand and this is my supply. So here I have more than I need considering my demand. I'm going to turn some of these points off because I have a lot going on. But as I get closer to that equilibrium point, my demand is going up, but the supply is going down. That's the way it works, right? So then as I get past that, I have more of a demand than I have a supply. And this is what we're looking at in our food and supply and population growth. Although in the lab, my demand, if you will, is going to be the people that I need to feed, and that is exponential. I'm going to get rid of this line right here. I'm just going to delete all that, and I'm going to put in a exponential that would be somewhat similar to what you were working with, and I'm going to change up my other line a little bit too. So let's say it was like 6, and then I would need parentheses, right, because it's 1 plus or minus r. And I'm going to say that it was 1 plus, let's say, 0.5%. So this would be well, actually, I'm going to say a whole percent. So that would be 101%. So I'm going to put the 1. And then to get to exponent, I'll just use the caret key, which is going to be Shift 6. So that I have the exponent, I put the x up there. Now notice before when I tried to put it in a C, it kind of it thinks it's a scalar, it kind of gets annoyed. So when you are putting in your equations, even if like you said F for D or P for population, you're going to want to use X and Y. I'm going to change this so it looks a little bit more like what you had to work with. So I'll make that a 0.2, and I'll make this, I don't know, I'll make this an 8. How about that? And I'm going to turn this off for a minute. So it doesn't look very exciting, but I'm going to have to scroll out quite a bit so that you can then begin to see how that curve, right? So there's my line in the red, but exponentials are going to have a curve. And my exponential is people, and my red line was food. So I'm going to come in, maybe I'll put that x back in. If I'm over here, if I can find my oh, there it is. There's my x, because I have 100, so it's going to have to go up to, let's say, 400. Right? Let's say I'm right about here. That's probably about 40, right? So if I'm at 40, I'm going to have to scroll in. 40 years after time 0, let's pretend time 0 is 2000 just to make my life easy. And 2040, I'll have, this was probably in billion people. Let's say I have 8.9-ish billion people, but I can feed 16. So that's good news. But you see out here, it's going to start to flip. And so right now we're all good. I have more food than I have people until all of a sudden I get to this intersection point. And I'm going to move this out of the way just a little bit so I can grab it. At 215 and change. So about 2215, I have the same amount of food as I have people, right? So my food supply and my people match. So no brawls at Publix yet, but in a couple of months later, it flips. I'm going to scoot this over. Now I have more people than I have food. That's a problem. Now I have a shortage. So I'm going to have a shortage about 2,216. So that's how you can find out where the shortages are and when they happen. Now what you're going to want to do in the lab is kind of play with it a little bit. So what could we do to improve our situation? Well, what if I started out with, I think I started out with, what if we planted more every year and we doubled it? All right, so the line changes and you can see the intersection point gets further out. Now it's 300 years, but that's only a few generations. So now maybe we want to double this also. Oh, that didn't do much, right? We got a couple extra years, so we got 9 extra years. So 319 years after 2000, we're still going to have a shortage. So messing with the linear doesn't do too much. What if we have this? So half of 1 is a 0.5. Oh, that went down a lot. And so I could scroll. Oh, and now I've doubled the amount of time that I have. So now, of course, there's some flaws with this logic, right? These estimates are very, very rough, even though I gave you some links. This was just kind of something that you could play with the numbers and have it be a real situation. It assumes that we don't have any like new technology happen in a good way, and that the Earth doesn't turn into one giant fire and we can still grow things, so in a bad way. So it assumes that everything stays as it is right now. But it's something to think about, if we have a shortage 600 years out, what could we do now, because it takes a long time, as you see, to effect change, that maybe we could push this out even further. So that's how you're going to use Desmos to help you with that lab, and it helps you find these intersection points. So you're looking for the X point. That's going to tell you the years after which you started. And that's how you use Desmos, and that's what the intersection points mean.